So after talking about the first law of thermodynamics, we should spend a few minutes just talking about the process in which work or heat can be delivered into a system. There are three primary processes. The first process is called isobaric. Now, if you know what a barometer is, it's an object that measures pressure. So iso is a system where pressure remains constant. So when we're talking about an isobaric system, we're saying pressure inside that chamber on that gas that's inside of a chamber remains constant. So when we look at isobaric, we're looking at a change in an object's volume. So if I have a piston right here, and the pressure inside the piston remains constant, okay, so the pressure inside of here remains constant, and I were to reduce the volume in there, okay, that's an isobaric system, as long as the pressure remains constant. Now, in order for that pressure to remain constant, things must be done. I mean, you can't do that. It's like expanding a piston and having the pressure remain constant. Imagine, if you will, a balloon. Take two balloons and have them tied together, one that's full and one that's not. One has a particular amount of pressure on it. That's why the balloon is allowed to expand. The atmospheric pressure inside that balloon is allowing it to have that volume. Now, as soon as I open up the valve, what ends up happening is the volume is now doubled, but has the pressure remained the same? Probably not. You have to do a few things. You have to do work in that system in order for that pressure to remain constant. So what we like to say is that the pressure times the change in volume is equal to work. Okay, so the work done, or the work done by, is equal to this equation here. Now, is that justified? If we remember right, the equation for work is force times distance. Well, when we talk about pressure, we're talking about force divided by an area. And when we talk about a volume, we're talking about an area, okay, cross-sectional area, times a length. Okay? If these drop off, I'm getting force times a length, which is the definition of work. So pressure times this change in volume means that work is either being done on or by the system. So when you're talking about isobaric systems, this is how you're going to calculate your work. Okay? Because you're not really going to get a change, and you're not going to have work unless the volume changes. Remember that you have to have a change here. So as this piston is moving in, the cross-sectional area remains constant, but this length here is not. Okay? It started out being this long, and now it's only this long. So you've experienced a change in length. You've done work. Okay? Cool? So that's an isobaric system.